Hello everybody, this is Mikey N6IL, and today I'm going to tell you about my project to run NitrOS 9 ease of use on XRoar using its Glenside IDE emulation. So I'm going to go over a quick agenda so that you know what I'm going to be talking about today. I'm going to give a brief description about the project and how it got started. I'm going to give a demonstration of how you download the binary packages and run those binary packages. I'm going to give another demonstration on how you build the binary packages yourself, and then I'm going to have technical discussion about how the script actually works and what's really going on inside. So this project started from an email chain on the Color Computer mailing list. This guy, Edward, asked how he can get ease of use to work on XRoar using the IDE controller, and that he couldn't get it to work. And then somebody said, well, do you need a special file format? It actually turns out that yes, you do. There are some differences with the XRoar IDE emulation, and I wrote a script that allows you to take a stock version of NitrOS 9 ease of use, either 6809 or 6309, both work. Take the stock distribution, you run the script, and out comes a hard drive image, which you can use with XRoar. So I am providing both all of the source code and all the things you need to do this yourself. I am also providing binaries, which you can download directly from my GitHub site, unpack them, and you should be able to run the command line that's in those scripts, and you should be able to get it working without building it yourself. I'm also going to go over how you build it all yourself. So for the prerequisites, you need to have the XRoar emulator. The latest version is recommended. And the EOU IDE project, the releases page is where you download the binaries. So let me switch into this. So this is the web page for XRoar. XRoar has become my new favorite CoCo emulator because it can be built native for every platform. I run Linux. I'm actually recording this video on a CoCo Pi right now. So it works on CoCo Pi, it works on Mac, it works on regular Linux, it works on Windows, it works everywhere. So you can follow the instructions to download the binary for your platform. They have Linux, they have Mac and Windows. So follow all of the instructions and recommendations to get your XRoar running first. That's a prerequisite here. And then the second prerequisite is if you go, this is the releases page. And here we have the two binaries. It's marked as EOU IDE 6309 bin, which is the 6309 binary package, EOU IDE 6809 bin, which is the binary package for 6809. If you wind up on the main page, this is the main EOU IDE page with the README file. If you want to get to the downloads, you see where it says releases over here on the right. You click on releases, and that gets you back to this page. You download these two binaries into someplace on your computer. So you have XRoar, and you have these two binaries, and that's really all you need to do this. So I have the two packages already downloaded here. I'm going to unzip the 6809 version, which is what I'm going to be demonstrating today. This comes with the hard drive images, everything, the ROM that you need, everything is included. So XRoar is going to be booting the 68 IDE to IDE image. I've included an HDB-DOS ROM image for the emulator, and I also have a script which you can use to launch XRoar. So taking a very quick look at the script, these are all the options that you need to give to XRoar to get it working. You need to tell it that it's a CoCo 3. I don't like, I want it to start in the RGB mode, so you can tell it that. Tell it to use the IDE cartridge. Tell the IDE cartridge to use the HDB DOS ROM, and then you load the hard drive image, and that's pretty much all you need to do. Since I'm here on Linux, I can just type bash start IDE.sh. I just need to make this window a little bit smaller. Let's get rid of this guy and this guy. And here we go. All right, so my emulator is running now. All I need to do to boot this up into NitrOS 9 ease of use, I type DOS, it boots up. Booting, booting, booting. I need to enter the date and time when it gets there in a moment. 2021. Oh, it has the key click. 12. This it's a little bit laggy because it's on the CoCo Pi, so we'll see how this recording comes out. And the time is 12:18 and 25 seconds right now. All right, it's doing a little bit more loading. Let's let this thing go as fast as possible. Do do do. Whee! Super speed CoCo. All right. So if I switch screens here, push the clear key, I can prove to you that it's actually running off of the hard drive. If I do dmode/dd, then it says FF50 and RB Super. So this pretty much indicates that you're running off of the hard drive image, and the sector offset is also in here, which is important for getting this image to work. So uh, if I really wanted to, I could come over here and type G shell and let this thing run. And there we go. I don't think I have a joystick configured. Right joystick, it says joystick 0. I don't think that's the right one. Yeah, I don't have a joystick configured, but let's just for fun. Yeah, there you go. I can operate this thing. I don't know why the colors are like this. TV input RGB. Weird. Oh well. Anyway, that's clearly working. I can do whatever ease of use stuff I want. All right. So going back to. All right, we just gave. I forgot to go to this slide. I just gave the demonstration download and run. And again, you can download it from this URL here, EOU IDE releases page, and you can download the binary packages. You don't have to worry about running any fancy scripts, Python, anything. It should just work. All right, now we're going to enter into the do-it-yourself section, how you actually build the images, how the images are built. So in order to build the images yourself, you need to have some version of Python. The script has been tested with both Python 2.7 and 3. It works on perfectly fine on both. CocoaPi still has 2.7. Most other Linuxes have moved on to Python 3. You of course need XRoar. You need a toolshed project because those tools are used to create the disk images. You need NitrOS 9 ease of use. And of course, you need EOU IDE. So on my machine here, which is CocoaPi, I already have Python, and I already have XRoar, and I already have toolshed. I've already downloaded NitrOS 9 ease of use, so yeah. Let's go straight into the second demo where I'm going to show you how to build these disk images. Okay, so starting with the web browser, again, you want to have XRoar. You need to have toolshed, which if you're on a CoCo Pi, is already here. Toolshed is a set of tools which you can run on Windows, Linux, or Mac, which can be used to copy files, format disk images for both Disk Extended Basic and OS9. It's very cool. I like Toolshed. I use it all the time. You need to have a copy of NitrOS 9 Ease of Use, which if you go up to the top of the page, you can just click this link right here from the top of the page. It goes straight to the download section, and you can download either the 6309 or the 6809 versions. Both are supported in this UU IDE project. Then the last thing you need is the actual UU IDE project. There are two ways that you can get this source code. You can clone it with Git, which is what I'm going to do. Um, you can also, if you really, using Git is actually the recommended way. If you go to the releases page again, they do have source code packages which you can download, but using Git clone is the recommended way to do this. All right, let's go into our demo. So, as I already said, I have UU already downloaded. I need to get the UU IDE project in here. So I just do git clone. It's very small. All right. Let's do a little bit of unzipping. Unzip the 6809 EOU 6809. So here's the 6809 one. And we need the same thing for the 6309 one. So if I take a look at 6809, all of the 6809 EOU files in there. If I take a look at 6309, all those files are there. All right. So to run the EOU IDE project, you do Python and make boot file IDE. It requires a couple of command line options. So you type -c and you tell it what kind of CPU you want, 6809 or 6309. And then you give it the location of the hard drive image that you want it to put inside of the disk image that it creates. So we're doing the 6809 one here. So I have that 6809, and the image that comes with EOU is this 68sdc.vhd hard drive image. So this is how you run the script. You hit enter, and it describes it's copying, doing all these different operations. It's pretty fast. When it's done, it basically tells you the output is in this build directory. Let's take a look at that. So in this directory are it basically has all of the working files. It has the kernel IDE that it created. It has the OS9Boot file that was created. I'm going to go over what's inside of these and how they're built. The README is here, script is here, ROM is here, everything is here. Most importantly, these are the disk images which were created. So again, we're going to be using this 68IDE.IDE image. This one is the one which is used for XRoar. So just like before, if I just do run this start IDE script, it's going to be exactly like it was before when we downloaded the binary. If I type DOS over here and let it run, then it's going to boot, 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 UU. Yay! Right, we don't need to see this whole thing over again. Yeah, this will boot up the rest of the way. So I can do exactly the same thing for 6309. So Python make, I need to go back on directory. And you just say CPU is 6309 and the input is 6309. I invented a new CPU, 6308. Wonder if that really exists. 63 SDC.VHD. It's just like before. Now in your build directory, you have 6309 and 6809. So I'm not going to demonstrate 6309 at the moment, but I'm going to go on in the presentation here, and I'm going to explain how this actually works, what's involved with creating these disk images. So we already mentioned that the current way that the XRoar IDE emulation works, it does require a special header. The hardware does not actually work exactly the same way as physical hardware. So there's some driver patches that are required. Um, the IDE port is currently stuck at FF50, which if you try to use NitrOS 9 modules, the defaults are, I think the defaults are usually FF70 for IDE versus XRoar is on FF50, so that has to be changed. We have to make a special boot disk, and we have to have an offset. So these are all the special things that we need to do, and this Python script takes care of all of these things. So generally speaking, I'm not going to go through every single one of these in detail, but these are the high-level steps that the script goes through. It copies a bunch of since you're starting with an EOU drive, it copies some modules straight off of there. I can explain which modules get copied, but that's kind of outside of the scope of this video. Um, the EOU IDE package on GitHub provides its own special modules for IDE, boot IDE, and the actual LO IDE driver and the descriptors. There's some patches that go into all of those modules, so I'm providing those. We create the IDE kernel, we create a new OS9Boot file, we make a new boot disk, we create a VHD hard drive, which could potentially be used on physical hardware. It doesn't quite work, but it could be if things get adjusted properly. Then we copy the EOU distribution VHD into the hard drive image. We put the header on the front so that XRoar can actually use it. Copy some miscellaneous files. So these are the steps that this Python script actually goes through. So we're going to talk about the NitrOS 9 kernel file, which is one of the earlier things that this script does. The kernel file is the file that is on track 34 of your boot disk for NitrOS 9. When you type the DOS command actually loads the entire contents of track 34 into memory, and then it executes it, and that's how NitrOS 9 boot actually works. So the kernel file is actually composed of three modules. Rel, which does relocation, boot, which loads the OS9Boot file from the drive, and then kern is the kernel file. So EOU has a specially modified kernel, so we need to get it from EOU, and this EOU IDE project has a modified boot IDE module. So what this script does is it puts all of these things together. We remove the original boot. The original boot file has CoCo SDC in it, and so we remove that one and we replace it with the boot IDE, which comes from me. We put these together, and this is the new kernel IDE kernel track. So that's the first step that's done. The next step is the script actually implements its own, I wrote my own version of a tool called QuickGen, which allows you to insert and remove modules in an OS9Boot file. So the one that comes from EOU has the SDC modules in it. So the script runs the quickgen in my Python script, removes all of the old modules, and it gets replaced with the ones for the IDE. LLIDE, the I0 descriptor, the I1 descriptor, and the DD descriptor. So now the OS9 boot file, which is being customized to run on IDE, is complete. We can move on to the next step. So the next step is we put all of these together onto a floppy, a bootable OS9 floppy disk. This is an image. So we're going to call this 68IDE.disk. And this was generated by using toolshed. We run the OS9 format command, which generates a disk image. And then when we run the OS9 gen command, which is the one that you actually use to create the boot disk, you tell it, here's my kernel file, here's my OS9 boot file. It copies them onto the disk image. And that's actually how you create a bootable, a boot floppy for OS9. So again, this is an image. Okay, so now we have our boot floppy image. We're ready to go on to the next step, which is creating the hard drive image. So the first thing, you'll have an empty box here for the hard drive image. The first thing that we put on the hard drive image is we need to put that boot floppy image. So that goes on first, and that is exactly 630 sectors, which those of you who are really technical will notice that it's not 160K, it's actually 322K. The reason for this is extremely technical, but IDE has 512 byte sectors. So in order for the ROM, the HDB-DOS ROM, to read stuff, you have to put it, HDB-DOS only reads the first 256 bytes of every sector. It throws away the second 256 bytes. So you have to do special padding, but it's still 630 sectors. So after we have this disk image, the boot disk, which is on drive 0 for HDB-DOS, then we basically copy in unmodified the EOU hard drive image, the VHD image which is given by EOU. And the important thing to note about this is in this disk image, the EOU hard drive starts at exactly offset 630 sectors or 276 in hex. So all of the drivers which are used in this have the offset of 276. They know to ignore the first 630 sectors of this disk image. NitrOS 9 will ignore them. It won't touch them. It doesn't actually know at all that the beginning part of this disk is an RS-DOS disk. It has no idea. It just knows starting my 0 is actually starting at sector 630. That's all that it really knows. So this is a VHD image. This image could potentially be used on physical hardware. It does not currently work. We're in the middle of testing it, but the point of this project was actually for getting this to work in XRoar. So in order for it to work with XRoar, there's one more step that we have to do. We have to put the IDE header on the front. So IDE header is 2 sectors, and those 2 sectors are completely invisible to the CoCo. It doesn't really know anything about them. It's a special header for the XRoar IDE emulation that tells it what the drive is, how big the drive is, how many cylinders, heads, and sectors, and all that stuff. But this header is completely invisible to the CoCo. And that hard drive image is the one that we actually load up in XRoar, and HDB-DOS boots from the RS-DOS section. When it transfers over to EOU, then it ignores that and it just does the EOU stuff. So that's how this hard drive image is put together. All right, that's the end of this presentation. So I just have the references here again for all of the bits and balls, pieces and parts that you need. Again, XRoar, toolshed, NitrOS 9 ease of use, and this EOU IDE project. All right. Thanks, everyone. See you in the next video.